Today we are going to solve some of the questions. So here we have first reaction. So in the first reaction we have this is NiPr and CH3NO2, and here we have base, that is NaOMe. That base abstract hydrogen from this methyl group, so we'll get a CH2 minus NO2. So now the delocalization will be this way. So now this CH2 goes and attacks to this carbon. So finally here we'll get a this product. So this is product A, and next we have a titanium chloride in the presence of H2O. So this is very important reaction. So because this reaction is called as a NEF reaction. So just remember, in the NEF reaction, methyl nitrate or any nitro group converted into aldehydes. This is called NEF reaction. So simply this NO2 gets converted into CHO. NiPr. So here this will gets converted into aldehyde. So this is our product B. So NEF reaction is very important reaction. So many times they have asked in examination point of view this reaction. So I hope there is a mechanism also for this reaction. I am not explaining here mechanism, so it's better to go through mechanism. So just remember that NO2 converts into aldehydes in the NEF reaction. And here we have a lactones, OPHT. This is the tetrahydropyran. So tetrahydropyran is the alcohol protecting group. So here we have in the first step lithium aluminum hydrate in the presence of THF as a solvent. So in this case we know that this lactone cyclic ester converts into alcohols. So we'll see how it gets converts, and then this will be converting into OH, and this is also converting into OH. And now we have a sodium hydroxide and H2O. This is for workup process, and we have HCl and methanol also. So this HCl and methanol we can HCl and methanol will deprotect this tetrahydropyran. So in the acidic medium this protecting group will get deprotect. So finally here we'll get here OH, and then here OH. This is like this, and this group also here will get a OH. So this is the product A. Don't get confused. So we have a cyclic ester. Cyclic ester converts into alcohols in the presence of lithium aluminum hydrate, and also here we have HCl and methanol. So acidic medium deprotect this tetrahydropyran. So here also we'll get a OH. So in the next step we have a sodium NaIO4. So this NaIO4, when we have a 1,2 hydroxy compounds, okay, so in this NaIO4 the reacting species is IO4 minus. Okay, so when we have a 1,2 dihydroxy compound where this is IO4 minus, okay, so this hydrogen, this hydrogen and this OH will remove as a water molecule, will get removed as a water molecule. And now the lone pair which is present here, that goes and attacks to the iodine, and the lone pair which is present here, that comes and attacks to this carbon, and now it becomes O, and here also O, I, and double bond O minus, and double bond O. So now there is a cleavage will takes place. So this bond goes like this, and this bond comes like this, and this goes onto this iodine. So here we'll get a 2 moles of aldehyde plus IO3 minus as a byproduct. So if we see the here I wrote the mechanism because here we have 3 hydroxy groups, so we need to know which 2 hydroxy groups will react. So just remember that only 1,2 dihydroxy group will involve in the reaction. So if we apply the same mechanism here, so this will come out as a CHO, HCHO, and this will get converted to CHO. So here product looks like this: OH double bond H and plus HCHO. So this is the product B. Next we have CrO3 in the presence of H2SO4 and acetone. This is called a Jones reagent. Okay, so in the Jones reagent, the cyclization will take place. Jones reagent, in the presence of acid catalyst, there is cyclization will take place. So this lone pair goes and attacks to this carbon and just give numbering 1, 2, 3, 4, 5. So there is a 5-member ring formation here. 1, 2, 3, 4, 5. At the first place oxygen we are keeping, and second at third place this group comes, and fourth place nothing is there, and in the fifth place we have a OH. So and now this is something like hemiacetal form, but this is not that stable. So to get stability, it gets converted into so this is the final product. Okay, so here in the first step we have lithium aluminum hydride that converts this cyclic esters into alcohols, and further we have sodium NaIO4. So this NaIO4 converts the 1,2 dihydroxy compounds into carbonyl compounds, and we have next Jones reagent. Here cyclization takes place, here hemiacetal form, and this hemiacetal is not that stable, that will converts into this form. So this is the final product here we will get. And then this is third reaction. Here we have OH, CO2, Me. Okay, so here we have a first step, we have TrCl. So TrCl means triphenyl methyl chloride. The structure looks like this: Cl, phenyl group, phenyl group, phenyl group. So just here we need to remember this, very very important, because in examination point of view there may be questions where we have a hydroxyl group as well as primary alcohol as well as secondary alcohol. TrCl is a protected group for alcohols. Okay, now we need to know which alcohol will be protected. So the priority will be primary is more reactive, then secondary, then tertiary. This is the reactivity order towards the protecting groups. Okay, now here we have a primary and this is a secondary. So TrCl protect this OH, this primary OH. So here the product will be, this will be OH and this will be OTR, and this CO2 Me. So in the next step we have another protecting group, that is TBS O triflate. So this is also protecting group. Now this protects this secondary alcohols. is OTR, and this is OTBS. Okay, now we have a CO2 Me. Okay, so in the next step, this is the product A, this one. So in the next step, we have a lithium borohydride. So we know that lithium borohydrates converts the esters into alcohols, right? So this ester converts into CH2OH. So here the product is OTBS and OTR CH2OH. So this is the after third step, and we have a here PH3P and I2 also. So this reaction is very important. So first I will explain mechanism, then I will go for the product. So here we have PH3P plus I2. So after reacting, it will convert to PH3P plus I and I minus. Okay, so now we have a alcohols here, ROH. So now we know that phosphorus have a strong tendency to form a bond with the oxygen, right? So this iodine and this hydrogen get eliminated as HI. Now we have a PH3POR. This is plus because phosphorus oxidation state is here 4 and I minus. And now to get stabilized oxidation state, that is plus 5. So this gets converts into PH3PO plus alkyl iodide. So when we have a PH3P and I2 and it's upon reacting with alcohol, we get a alkyl iodides. So just keep it here. After reacting with PH3P and I2, we get a iodine. Just iodine will get here. OTR, OTBS and iodine. So this is the final product. So this mechanism is very important. Okay, so we have PH3P and I2. So first we'll get this one, and here we remove HI and we'll get this product, and further finally we'll remove PH3PO and we'll get alkyl iodides. Next we have lost this reaction. So this one we can use as a alcohol protecting group. This is called tetrahydropyran. OT, tetrahydropyran. Next we have a methyl magnesium iodide. Here we'll get this OMgI and methyl group. Okay, and further we have here OTHP, and then it gets converts into, this is the product A. Okay, next it gets converts into in the presence of acid catalyst, and then this will be OH, methyl group, OTHP. So here now we have heating also here. So whenever we are heating, this is the acid sensitive protecting group. Whenever we are heating in the presence of acid, this THP will come out. So now here we will get back OH, and also here this elimination of this water molecule takes place. So now we'll get this product. CH3 CH2OH. So this is the product B. Okay, so next we have in the third step we have PCC. This is the oxidation takes place here. So primary alcohol converts into aldehydes. And next, in the fourth step we have chromium trioxide H2O2 in the presence of acetone and water. So this is called Jones oxidation. In the Jones oxidation, aldehydes converts into carboxylic acids. So this is the final product. So in the first step we have we are protecting OH with this tetrahydropyran, and in the second step we have Grignard reagent and further elimination of water, and here we have PCC oxidation. PCC oxidation converts primary alcohols into aldehydes, and further this aldehyde can convert into carboxylic acid in the presence of Jones reagent.